Okay, now we're going to review ionic compounds, which is our first flip chart, troops. Okay? Remember on our first flip chart, okay? This right here. First flip chart was, we always look at that stair step. And if the stair step first compound, which is always the first one there, if it's on the left, we're going to use these rules. Remember, that was the one that might have been a little difficult, that took the old yes and no, what is a D and a P block, okay? All right, so following the simple rules, all right? So here's the first one, ALP. So we ask ourselves, aluminum, is it a D block? Yes, it is, because it's on this side of the stair step. So I follow those first rules. Remember, the first rule said in your sheet was, name the first cation, which is the first element, which is aluminum. That's what I did there. So I'm just going to do what the answer is right out here to the side so you see me working. Aluminum, okay? All right, then the next thing I ask myself, remember, yes or no question, is aluminum a D or P block metal? Okay, so that's when you looked at your periodic table, okay? D blocks, remember, are all the yellows and then everything on this side of the stair step. Okay, so basically from here over, and yes, aluminum's right here, so it's on this side of the stair step. So we say yes. So then that is the part where the key thing is, remember, any D or P block metal is going to have a Roman numeral. Okay, so that's the one rule that is tough, and we've been doing it, but I wanted to give you a video for those that need review on it. You can watch this multiple times if I'm not there, or you're not there, especially we're getting closer to that little short quiz. You just took a quiz over covalent, which was name it as you see it, which was the easier of the two, but I needed to go back over this. Okay? So the biggest thing is there, then we look at the anion, the second element, and always, when in doubt, check the charge. So you look at your periodic table, and P we know is phosphorus. Phosphorus. I probably spelled that wrong because I'm the best speller in the whole wide world. And if we looked at our periodic table, we notice in the column that phosphorus has a -3 charge. Okay? So we ask ourselves, when we looked at this formula, why is there no 3 down here below? Because we're experts on crisscrossing, right? So we know if we drop the charge, the 3 should have been over here with the Al. And why is it with the P over here, there's not a 3 as well? Oh, which tells us this must have been reduced. So that is where the aluminum 3 Roman numeral came from, because you remember, it's all about, we need to know if it's a D or P block, what Roman numeral charge is with that cation, that first element, okay? And that's the only one that ever changes. And then once that's done, remember the last rule says, name it as you see it, okay? Or name the anion and add IDE. So phosphorus, okay, because we had aluminum 3, and then phosphorus went to phosphide because it says right there, after I uncrossed it and the metal first element, write the Roman numeral, that's what I did. Name the anion, add IDE if by self mono. If it's a polyatomic ion, which our polyatomic ion sheet, we just name it off the sheet, okay? So that's why phosphorus went to phosphide, all right? So aluminum 3 phosphide. Okay, a little review on that, okay? Let's take this one right here. This one's a little more textbook. Zinc 2 nitride, okay? Well, we know that zinc, obviously, write it out, zinc, name the cation. And we know that zinc is a clear D block metal, all right? We look on our periodic table. And I'll even hold up here, zinc's right there, all right? D block metal. So then we figure out, okay, look at the anion. And that's why I know you hear me in class, we're running. When in doubt, trying to find, look at the charge of the anion before you uncross them. So nitrogen is in a -3 slot. So nitrogen, okay, we know has always a -3 charge. So when we dropped it and brought it down, why do we look at this and we see zinc clearly has the 3, so that makes sense because that's how we crisscrossed it and made it. So that should be the dead giveaway if the 2 then is over, if the 2 is over here. So when we uncross that, that's where we must have got zinc 2 because that was a clear uncross that one, all right? And nitrogen went to nitride because we know to change the ending to IDE when we're done. So thus, that's where we got zinc 2 nitride, okay? So hopefully that, by just doing a couple review, I'm not gonna do the whole thing, and I didn't want to spend on this is like 4 or 5 minutes, all right, and so on. So when you have polyatomic ions, that's easy. You name it as you see it. Like for example, on this one, NH4 is clearly not a D or P block. It's just a polyatomic ion. So you looked at your polyatomic ion sheet, and it's ammonium, and then that's just sulfur goes to sulfide. All right, sulfur goes to sulfide. This one here, there's no Roman numeral because we know sodium is not a D block because it's in the first or second column. So we just keep it as sodium. Fluorine goes to fluoride. Okay, so remember, the only big rule that really makes you think really deep on is that if it's a D or P block metal, and we got to figure out the Roman numeral. So those are the ones you're really applying that yes or no question, all right? And you got to think of, I have to look at the charge of the anion, the second element, because when I uncross them, that's how I know which goes where. And I need to make sure that I know them because maybe they were reduced, and I got to make sure I have the right number. Okay, those are the tricky ones. And like a lot of them, like for example, this one, number 10, dichrominate, Cr2O7. Well, that was easy because I know K, potassium. And we asked ourselves, is that a D block? No, because potassium's clear over here. That's outside. It's not 3 to 12. Remember anything of that? So that was easy. I just named potassium. And then Cr2O7 was a dead giveaway. Oh, it's polyatomic ion. So I looked at my polyatomic ion sheet that Meyer gave us and said we can always use. I'm looking for an extra one. They're here somewhere. Oh, where'd they go? Oh, shucks. Where'd they go? Oh, here it is. Remember your polyatomic ion sheet here? All right, you can always have, there it is, C2O7, dichrominate. So I just wrote it in, okay? So it's not as hard. There's a lot of steps, but you also have your periodic table, always. You have your polyatomic ion sheet, always. And you have your flip chart. Always. So you have all the steps and rules. If you'll follow these rules, you'll always get the naming right. So that's ionic review, okay? One more review.